Welcome to Phyclops. We listen to plants. Today, I want to talk about a mystery signal. A mystery signal that I came across while recording voltage profiles from various plants under various conditions. So this will be a session on plant voltages, and we've had 2 other sessions on this already, but this one is going to focus on the mystery signal. And it really deserves this name. You will see why in a moment. As I've mentioned, I'm recording plants in different settings. You've seen the outdoor recording that I'm doing. Let me try and draw stylized conifer tree here. I think I'm getting the hang of it now. Huh? So there's a little conifer that I'm recording in an outdoor setting. And there are other plants I'm recording. Some of them potted. This is turning into a real art session now, but I keep it short. Anyway, some outdoor, some indoor, some potted, some wild, all of them attached to these 2 electrodes and a recorder. So I'm recording voltage profiles for them, and I've shown you an example in the first 2 sessions of plant voltage recording and their understanding. And these voltages over time look not very spectacular, but they can tell us a lot. So doing this over more than a year and a half on different places, in different situations, I've come across this one example, which I call a mystery signal because I kind of have an idea of what it could be related to, but it's really a bit too wild to be definitive about that, this being really the case. So I wanted to show you what the signal looks like, and maybe anyone out there has an idea or has seen this before or can give me their opinion on whether what I'm proposing here actually makes sense or not. So signal in our case, I call any distinctive feature of the voltage recordings that we are making here. This is time on this axis. These are the voltages. And the signal can be any distinctive feature that we can somehow identify in the recording and relate to a plant state or an event happening to the plant. Right? So, talked a lot already. Let's show you the signal. This is a recording I made between the 30th of August last year, 2022, and the 14th of September of the same year. You're seeing two parts here, the top part and the bottom part. Both are the result of processing the original voltage curves in certain ways to extract certain properties of the curve and make them visible in different ways. So the two distinctive features that you already have spotted already are, when you look at the lower half, the lower graph, there are these two large dips, these two valleys that happen. The first one happens on the 4th of September, so between 4th and 5th of September midnight, and the second on the 10th of September around midday, maybe a bit earlier. The second one, the one on the September 10th, I'm very confident about what that is. I know exactly what happened to the plant when this recording was made, and I know this reaction. I've seen it a lot in other plants and also in this same plant at different times. So the dip that we see on the September 10th is fairly well understood. Now we come to the one on the left, the one on September 4th. You see the dip starts happening about almost exactly at midnight and then goes on to noon, September 4th, and then starts to recover until midnight the next day. So that was something you can see in the lower half, and in the upper half you can also see that the dark region there is similar to the dark region that we get for the September 10th. And for the September 4th signals, I really, when it first occurred, when I first looked at the data, I had absolutely no idea what this could have been. This is an indoor plant, a potted indoor plant, so it's not exposed to many drastic environmental changes. The changes, or sort of, let's say, the actions that I can do are, I can control when I do them, and so this is completely unexpected because this was, the 4th of September was in a day where the plant hadn't been watered for some time. It was a sort of normal day, no extreme temperatures. Anyway, sits by the window. Temperature, because it's an indoor plant, is fairly constant, somewhere always between, let's say, 16 and 22 degrees. Anyway, there's nothing special happening on that day. So I kept thinking about this, and then sort of by chance on social media I came about an event an event that happened on that same day, a global geomagnetic storm event between the 4th and the 5th, actually starting earlier, but between the 4th and the 5th it had its peak. Geomagnetic storms. Just briefly, what are they? Geomagnetic storms happen when the sun, for some reason, ejects a lot of mass, charged particles into space, and all that mass of charged particles travels to Earth, hits the Earth magnetosphere. When it does that, it is on the night side seen as northern lights. On the day side, you can't see it. But what these mass ejections do is they cause if they are very strong, they cause great problems in satellites and in all kinds of electrical devices.